Okay, now this is a very, very important formula equation in current electricity. This is called the Ohm's Law. So here you are shown the relationship between resistance, current, and voltage or potential difference. Okay, this means so the potential difference or the voltage across A and B is equivalent to the current flowing throughout A and B times the resistance that you can find, the sum of the resistances that you can find between A and B. Okay, but actually this is more useful if we look at it this way. If we divide this by current, you will have R equals over I, voltage over I. So if you increase the resistance, you will lower down the current. Okay, the smaller the current will be. And then if you oopsie, okay, wait, it's useful, it's much better actually if we get this in terms of current. If you divide this by R, there you go, that's better. The same naman, no? If the resistance gets larger, inverse ang relationship nila, diba? Current will be smaller. And then if the potential difference is, let's say, higher, the current will be larger as well. Okay? This is the Ohm's law. Okay, you can see it here, the relationship. Let's take a look at 1 and 3 first. So, voltage, you added a battery, no? Naging 4.5 na yung voltage mo. The resistance is the same because, well, you only have one electrical load. This will result to, if you triple the voltage, that will also triple the current. And let's take a look at 1 and 4. Now here, it's both 1.5 volts, but you double up the resistance. The current will be divided by 2, will be half. Okay? Current increases if the potential difference across the circuit increases and the resistance decreases. Or that's very misleading. And if the resistance decreases, current increases. Okay? Mixer. This is an example. So this mixer is capable of performing other function. So aside from mixing, which is very mabilis, diba? Yung movement nung, diba? There's parang, wow, I don't know what it's called. Mabilis yung ikot niya if it's performing mixing. And then it can also perform beating, like an egg, beating the egg. So that will be, the movement will be slower. Okay, so actually this machine can somewhat change the resistance, its own resistance. So if you push the button for mixing, kailangan niya ng mas maraming current, diba? So pushing that button will lower down the resistance of the machine. And then if you want to perform beating, that will not need much current because gusto mo mabagal yung movement, yung circular motion ng beater. So you will increase the resistance once you push down that button. Okay, that means mas onti yung current because when you say resistance, it's slowing down the flow of charge. Okay, that means mas kakaunting charges ang nakaka-pass through a particular point in the circuit over time. Okay, now that we have introduced the Ohm's law, we will be able to develop another formula for power. Okay, so we will end up having 4 different formulas for electrical power. So P, diba? V equals IR. Now if we substitute IR here, diba? Here, now I have P equals I squared times R. But I can also substitute the Coulomb's law. No, not the Coulomb's law. Ohm's law here. So I will be over R. So in that case, it's the voltage that will be squared. Okay? Okay. So remember that. P equals I squared R, P equals voltage squared over R. So let's use that in calculation. Suppose a 60-watt bulb in a household lamp was replaced with a 120-watt bulb. Then how much times greater would be, or would the current be in that lamp circuit? Okay, let's solve this in two ways. So first, using the original formula, voltage times current, and then the formulas that we just derived. So for the 60 watt first, kasi ko-compare natin yung, diba, yung current. So we have to solve for the current on both of the bulbs. So 60 watt ang power niya, let's say 120 volts yung ating yung ating potential difference across the circuit. Current, let's divide this by 120 volts. Okay, so 60 divided 120 is, of course, I still use a calculator, 0.5. Current is in terms of ampere. If you use the same process for the 120 volts, or watts rather, so of course, that's going to be 120 watts divided by 120 volts, that's going to be 1 ampere. Okay? Now, the question is, why is it that current is larger for the 120 watts and then it's lower for the 60 watt bulb? Actually, it's due to the resistance of the bulbs. Let's compute for the resistance using the from VIR, no? What? VIR? Okay. Resistance is equals to change in potential or potential difference over current. So for the 60 watts, the current ay 0.5 lang, diba? So 120 divided 0.5. 240 ang kanyang resistance na ina-offer. Meanwhile, 1 ampere. Ito, 120 resistance lang. Ohms lang ang resistance niya. That's why more charges are able to flow over a cross-section or through a cross-sectional area over time. And that leads to a larger current. Okay? So, resistance ang salarin, di ba? Now, just to demonstrate how, it's a fairly simple formula, di ba? Just to demonstrate, no? How to use this one. I squared times R. Power is 60 watts. Current, we're solving for that. Let's use the R ohms. Divide this by 240 ohms. 60 divided 240, 0.25 ampere square. I squared square, that square root of 1, 2, and 5. Did I do it correctly? Yes. So I will be getting the same amperage. Okay? Okay, so that's electrical resistance, everyone. I'll see you on the next module.